Hello and welcome to another episode of Double Word Physics. This episode is going to focus on electrical power. It's kind of a continuation of our stuff on energy. Where you have energy, you have to have power. Okay, for those of you who are watching from outside of Ireland, power, as I pronounce it, is power, and I can't do that on a continuous basis, so you're just going to have to get used to it being power. Okay, so power. Just like in mechanical energy, power is equal to the amount of energy you use divided by the time it takes you to use it. Okay, simple as that. I had a couple of questions about what this little slashy thing means. This means divided by. I would write it as a fraction as energy over time, but unfortunately this software sucks, and that's the only reason I'm doing it like this. Okay, so when you see this little slashy thing, that means divide by. So power is energy divided by time. But we know from our last video that you've intensely watched and worked really hard at, that energy is equal to, just delete that out, energy is equal to I multiplied by V multiplied by T. Okay, so if energy is I multiplied by V multiplied by T, then power is equal to I multiplied by V multiplied by T, and then all divided by T. Now, if you're super hot at maths, you should be able to see that that is equal to I times V. And if you're not super hot at maths, then fingers crossed you're just super hot, and then it doesn't matter. But just learn that P equals IV. And that's our key equation for this episode. The P is equal to IV. The power is equal to the current multiplied by the voltage. And that forms a little maths triangle like that. Okay, the P, I, and V. So if I want to find any particular one, I just make myself a little cover up to go around that. So let's take a nice green this time. And if I want power, I cover it up. That leaves me with I multiplied by V. If I want the voltage, I'm left with P over I. And if I want the current, I'm left with P over V. Alright. The unit for power is, as before, the watt, just as in mechanical energy, and it's got a symbol of capital W. So let's do a quick example. If I have, let's say I have a little resistor with 5 volts being used in it, and I've got 4 amps of current traveling its way through it, then the power is P equals I multiplied by V. That leaves the power is equal to the current, which is 4 amps, multiplied by the voltage, which is 5 volts. So that leaves me with a power of 20 watts. Big W. Okay, so big W is watts. And you should remember the power is the amount of energy used in 1 second. So this 20 watt resistor is using 20 joules of energy every second. That's really, really, really important. Examiners love that type of question. They get you to work out a power, and then they go, how much energy is being used every second, or how much energy is being wasted every second, or something that says every second. You've got to remember the power is the amount of energy used in 1 second. And that kind of falls from the energy equation. Again, if you're absolutely on the button with maths, that's obvious, and if you're not on the button with maths, then this is a remember me box. Okay, so just remember power is the amount of energy used in 1 second. A more complicated example would be something like this. We have a 26 volt battery with our cell polarities nicely labeled, it's plus and minus, because we're being posh today. We're doing conventional current, so conventional current travels from positive round to negative. Remember, conventional current was what they thought before they discovered the electron, and it was wrong, but they kept it because it really makes no great difference. So 1.2 amps goes that away into a 6 volt bulb and a 20 volt motor. And what we're going to be asked for is find the power of the bulb, find the power of the motor, and find the total power of the circuit. Because power works pretty much the same way as Ohm's law. You can do bits of the circuit or you can do the whole circuit, provided you know what's going on. So let's do the power of the bulb first. In our bulb, we want P equals IV is our equation. So the power is equal to the current traveling through the bulb. Well, it's a series circuit, so the current is the same everywhere, 1.2 amps all the way around. So we know the current is 1.2, multiplied by the voltage being used by our bulb, 6 volts being used by our bulb, so that is multiplied by 6. So the power in the bulb is equal to 7.2 watts. Okay, so 7.2 joules of energy being used every second. Simples. Okay, so the power in the motor, P equals I times V. You get P equals the current in the motor, again series circuit, so the current is the same everywhere, 1.2, multiplied by the voltage being used by the motor, which is 20. So P is equal to 1.2 multiplied by 20, which is 24 watts. is 24 watts is being used in our motor, and that is 24 joules every second. And then finally C, and this is the important part. You can do bits of the circuit or you can do the whole circuit. You have to know the whole information about the circuit. So V equals IV. V equals the total current in the circuit. It's a series circuit, so it's the same everywhere. It's 1.2 multiplied by the total voltage being used by the circuit. 6 and 20. 26 volts being used by the full battery, so 26. So P is equal to, and that works out to be 31.2. Right, watts. You can do that on the calculator, 31.2 nicely, or you can realize that if the bulb is using 7.2 joules of energy every second and the motor is using 24 joules of energy every second, then logically the whole circuit is using the addition of those two, which is 31.2 joules every second, and that's written as watts. And that's pretty much all there is to it. You can get given current and asked to find and power and asked to find voltage. We'll do that next time when we're talking about domestic electricity, because it becomes very, very, very useful when you're finding what type of fuse you need to put into a plug. Dear God, we might do something in physics that will be useful to you in real life. Okay, so I'll chat to you next time.